How's it going, folks? We are starting our first lab now, and I wanted to give you a little bit of a breakdown of what we're going to be doing so you can start thinking about how that's going to work. Okay, so the question that we're going to be studying for this lab is how can you tell if a chemical reaction has taken place when two or more substances combine? Okay, so after you watch this intro video, you're going to record at least 2 claims about how you can tell if a chemical reaction has taken place. And so what this lab is going to be doing, we're going to be mixing 2 chemicals together. All right, we have 2 different sets. We're going to be doing it twice. We have one that's baking soda and vinegar, and one that's potassium iodide and hydrogen peroxide. Okay, and we'll look at what those are. So let's think about what we're going to be doing. We need the materials. We need the foam cup where the reaction is going to take place. We need a thermometer to measure the temperature during the reaction. And I've already used the scale to measure out these materials. So keep in mind what you're going to be doing during the experiment. You're going to be taking the temperature before and after the reaction. You're also going to be observing the properties of the substances before the reaction, during the reaction, and after the reaction. Okay, so that's kind of what the procedure is going to look like. And like I said, we're going to do this twice, once with baking soda and vinegar, and once with potassium iodide and hydrogen peroxide. Same process, we're going to take the temperature before, during, and after. We're going to observe the properties before, during, and after, and we're going to determine if a chemical reaction has occurred. Okay, so I hope that was helpful in writing your claims. All right, folks, we're getting ready to mix baking soda and vinegar. See what happens. So remember, we should be recording our observations in our lab notes under the table number 1 and table number 2 for this procedure. Be sure to take the temperature before, during, and after, and make sure to make notes of the properties of both substances before they go into the reaction, what's going on during the reaction, and what we have after. Okay, so I'm going to go ahead and make this big so we can see this reaction. We have baking soda, so go ahead and note its properties. Okay, should probably be fairly familiar with what baking soda looks like. Okay, and we have vinegar, which might be easier to see in the bottle, right? We have vinegar. Okay, I'm going to go ahead and move it over into our cup, which is where our reaction is going to take place. Note the temperature as it is right now, just before the reaction begins. Okay, here we go. We are in the middle of the reaction. Go ahead and note what is happening. Note what matter you see. Okay, give a full description of that in your data table, and also notice what's happening to the thermometer. Okay, we're measuring the temperature and we might see some changes there. Okay, you can see that the reaction is starting to slow down. I'm going to give it a little swirl to make sure everything comes in contact with everything else. Give it another 30 seconds or so to complete the reaction. And then we'll take a look at the final substance. All right, we're going to go ahead and call that our final temperature. And I'm just going to move this over to a clear cup so we can take a look at its properties after the reaction. Okay, there's a lot of bubbles still in there. And that's our reaction. Hope that was helpful for filling out your data tables. All right, folks, we're working on procedure 2 now, which means in your lab notes, you're on table 3 and table 4. And this will involve 2 substances. One is called potassium iodide, and one you might be familiar with is hydrogen peroxide. Okay, so I'm going to go ahead and make this bigger. So hydrogen peroxide is, of course, this liquid that's in here. Okay, I'll go ahead and get a new cup, fresh cup, no vinegar in that. So in here we have our hydrogen peroxide, and I'm going to go ahead and add that liquid to the cup and take its temperature. Make sure you record that temperature and make sure that you think about the properties that you can observe about the hydrogen peroxide. Now, the potassium iodide is definitely a substance you probably have never seen or dealt with before. It's a lot like salt. It's kind of this granular white material. No real, that's kind of got a chemically smell to it, but it doesn't really have like a distinct smell that I could name. It's definitely like a salt in that it's crystals, okay? And so go ahead and write down some observations about this substance. And then we're going to go ahead and mix them. All right. And go ahead and observe these changes that are happening during this reaction and write them down on your data table as you do this. Okay, we're going to go ahead and zoom in a little bit so we can see everything we need to see. All right. I'm going to swirl it, make sure everything gets in contact with everything else. Okay. And note what's happening to our temperature. Okay, note how that's changing. We see that there's a definite change in properties here. Go ahead and list what those new properties look like in your data table. Identify, give us a full description of what's happening here. Bailey's trying to call me in the middle of this video. Not going to happen. You can actually see we're getting actually some bubbles flying out. That's what these little specks of color are. Interestingly, they turned purple on the paper, which is very unexpected to me, actually. Let me go ahead and swirl one more time. Just make sure everything is completely reacted. Right? This is a similar reaction to baking soda and vinegar, but it's different, right? There's definitely some different things going on. And we can see how that temperature ended up at the end as well. So I'm going to wait a second for that to possibly finish, just in case there's any more reaction happening. We can still see some bubbles forming, so that means stuff's still happening. Let's see if I can swirl it again. All right. And we can pretty much determine that that's about the end of the reaction. Don't see any more bubbles forming, and we don't see the temperature changing too much anymore. So I'm going to go ahead and turn that off. That's our final temperature. And now you see how that on the paper here turns purple. That's the iodine, I believe. It's my guess here. And go ahead and take a look at the final result. All right, so I hope that was helpful for filling out data table 3 and 4. All right, folks, you've watched the 2 procedural videos, you've made some observations, you've recorded them in your data tables. Now it's time to revisit your claims. So go back and look at your first question from this lab and say, what did I think would be evidence that a chemical reaction has occurred? And you're going to see if the data, knowing that both of those two procedures were chemical reactions, okay, does the data you saw from those chemical reactions support your claims about what would prove that a chemical reaction has occurred? If their claims were not supported, what would explain this? Maybe your claims were off base. Maybe some of the investigation taught you something new that you want to incorporate into your knowledge. But number 2 is for that. The big questions that I want to be focused on for this lab are 3 and 4. Okay, so for number 3, you need to look at this chart. Okay, think back to the PhET simulation we did about the law of conservation of mass and about what happens in a chemical reaction. Also remember that acetic acid is another name for vinegar. So remember we looked at vinegar. Vinegar's actually diluted with water, and the main chemical of vinegar is called acetic acid. So this is your baking soda and vinegar reaction looking at the models of the molecules. Okay, so think about what this chart is showing us. Think about the color scheme. And then I want you to answer number 3. How does the information in the chart support your observations about the properties of vinegar and baking soda before and after they combined, right? So properties. Those are the things that we could see with our eyes, not necessarily what you can see with these models. Okay, these models show our structure. What we can see with eyes is what we can tell about properties. Okay, so keep that in mind. And then last but not least, you're going to develop your own model where you're going to draw something similar to what we did on that PhET simulation, where you show the reactants, you show the products, and you show the relationships between them to show that this is following the law of conservation of mass and showing that mass is conserved. Okay, so I hope this was helpful in answering questions 1, 2, 3, and 4. Good luck.